All right, brand new little topology here. This is for inter-VLAN connectivity specifically, but we will incorporate spanning tree. We will incorporate port security. We will incorporate assigning VLANs and turning off, spanning tree and a whole bunch of stuff, right, that we've done. And one new thing that we haven't done or talked about, which is VTP. Okay, so the IP addresses are already on the PCs. First available host for the PC, last available for the gateway. So we have VLAN 10 over here, VLAN 20. You see I matched up the third octet with the VLAN. Now that you have to, I just do it for visualization. Then we have here, and look, I'll even change this for you. We'll put in here a www. Let's put it in caps. www. Let's put a web server out there, right? It has its public IP address because it's all ones. So we're making believe that that's going on. So first thing that we're going to do is, it's not the inter-VLAN. First thing we want to do is, we want to make this guy the root bridge. We'll do things at a step at a time. Root bridge. We'll make this guy the root bridge. So let's do that. And how do we do that? By changing the bridge priority. So let's call this, let's give him the appropriate name, config T. And we'll call him host name root. No, we won't call him root bridge. But we'll call him, I don't know, core. There you go. That sounds good. Core underscore SW1. All right, that's the core switch. So now we have multiple VLANs. We have VLAN 1, we have VLAN 10, and VLAN 20. So spanning tree, VLAN 1, comma, 10, comma, 20. We want the same instance of span tree across all VLANs. Priority 0. Yes, you must do that. At least for the CCNA. All right, you have multiple instances, but we're going to use one instance of span tree across all VLANs. Now, one new thing that we're going to do before we actually created the VLAN and assigned the VLAN in the same switch that we were in. Not in this one. Here, we're going to create the VLANs, VLAN 10, enter, name, we'll call it faculty, VLAN 20, enter, name, students. All right, we're going to create the VLANs up here, but we will not assign them to any port on the root bridge. We're going to have them propagate down to the client switches. Which brings us to what? VTP. I'm going to exit out of here. I'm going to do show VTP status. Well, it would be helpful if I put do, if I'm going to do that. Do show VTP status. Right? And this is important for you to know. This all switches by default are server mode. Okay, they're server mode. So this particular switch, since it's the root bridge, is going to stay that way. The bottom switches we're going to turn into client mode. All right, and the difference is, again, one can receive, change, send updates. The other server can do everything. Clients you cannot change VLAN. We'll put it simple. Clients, basically, you cannot do anything with the VLAN database. There you go. All right, everything else is all good to go, but you can't do anything with the VLAN database. So we're going to do the other two switches in client, and one last mode is transparent, but that's more for remote locations. I call them the greedy one. Anyway, so VTP is the operating mode. We're going to actually create a VTP domain name. So we go VTP name, or VTP domain, I should say. VTP, yeah, domain. We'll call it LAS. Okay, we don't have to worry about the version. We're not going to set a password on it, which in the real world we would. But here we're not going to change it to, we're not going to put a password. VTP LAS, or VTP domain LAS, and we look at the VTP status once more. Now you see that it says LAS. And this is important if you want things to propagate down, because we want the other switches members of our domain. And we're going to trunk the ports. Which ports are we going to trunk? We're going to trunk ports 22, 23, and 24. All right? Because those are the ports that the VLANs, other than the native VLAN, are going to go across. So we need to do that. So we're going to go into int range F0/22-24. 22, 23, 24. Enter. Switch port mode trunk. All right, cool. To WR. And we look at the configuration. Oops, Control Z. And we do that. Let's just look at it. Show VLAN. There's our VLANs. They're created but not assigned. Show int trunk. We have ports 22 and 23. Hey, what happened to 24? Well, since that port is really off because it's connected to the router and the router's port's off, that's why it doesn't show up. Once we turn on the port on the router, then it will show up. And we're doing 802.1q trunking. All right, we do show spanning tree. And you see that we have for VLAN 1, okay, this is the root bridge. Okay, you see here. Let's hit enter. Okay, this is the root bridge. All right, for VLAN 10, you see it's 10. There's a root bridge. And why did it cut off on me? All right, well, whatever. For VLAN 20, it will be priority 20. Okay. But anyway, so span tree is already working, and this is the root bridge what we're on. So cool, we're good to go at that point. All right. So now we're not having assigned an IP address or anything to the switch or anything like that, because that'll be VLAN 1. We may do that at the end. I don't know. We'll see. All right, because we did add VLAN 1 to the span tree. Now this one down here. All right, this is going to be faculty. This is going to be VLAN 10. VLAN 10 is faculty. Okay. So let's put this over here. Let's name the switch appropriately. Config T. Host name. Faculty. All right. Then we're going to change the client mode. BTP mode. Client. All right. And you can see up here, you see that once we trunk the ports up there, it automatically changed those states to dynamically trunked. And we'll look at them. All right. So let's verify that those VLANs came down. Do show VLAN. And they did. There they are. Oh, okay. It wasn't 20. I named it VLAN 2. You see that? All right. No big deal. It's VLAN 2. I didn't take the 0 for some reason. All right. What have you. So it's VLAN 2. That's why I saw 2. That's why I got a little bit perplexed there for a second. All right. But this is going to be VLAN 10. Here it is. And we're going to assign it to some ports. Okay. So we're going to go int range interface F0/1-15. That's normally what I normally do in all my labs. Oh, sorry. Int range F0. So it took me a while there. /1-15. All right, and now we're going to go ahead, switch port mode access. Remember, we got to turn to an access port. Switch port access VLAN what? 10, because that's faculty. Now we put in, now these ports are now part of VLAN 10. All right, but now that we're here and we've turned into an access port, let's go ahead and put port security on there. So switch port hyphen security. All right, that turns it on. I'm going to up arrow. We're going to do MAC sticky. Remember that one was for make a static entry in the MAC address table. Then we're going to do up arrow again. We're going to do a maximum of 1 again because we rule with an iron fist. And then port security violation. And we'll put viol for short, but the whole command will be violation. Violation we want to shut down. All right. Now, these ports that we're in, we know they're going to be for end devices. All right. So we really don't want spanning tree to be looking at those ports and taking forever to turn it into a forwarding state. So what do? We turn off spanning tree. And how do we do that? Spanning tree. And yes, I tab. You know me. Port fast. You can't. That turns off spanning tree. And it gives you a big, huge warning. Hey, listen, you can cause a problem if you're doing this. If somebody accidentally plugs in another switch, another type of internetworking device, all right, could cause a bridging loop or switch loop broadcast storm. So you don't want that. Well, tell everybody what you're doing, right? Everybody needs to know this information. But we can guard against that. How do we do that? By doing spanning tree BPDU guard, bridge protocol data unit guard, and then we enable it. Enable. Okay, so we successfully turned off spanning tree, and then we're guarding against it in case somebody that didn't hear the information that all these ports are now, no, spanning tree is not looking at it, they're being guarded against, and then if I accidentally plug in a switch, it will shut down the port as well. All right, so do WR, okay, Control Z, and we're pretty much done, okay, with what we wanted to do. All right, assign it. Really, just assign the VLANs. But again, we did everything else that we've done before, so we see everything on there through all the ports. We didn't do no basic housekeeping, obviously. Okay, and we didn't configure any tunnel lines or IP addresses on the switch yet. All right, so let's go ahead and go to the second switch. All right, and this is going to be the student switch. Enable config T. Host name students. Yes. Switch port mode client. Aha. BTP mode. Client. How about that one? That will work better, won't it? All right. And then do show VLAN. All right. And there is VLAN 2, where it should have been 20, but that's okay. So let's assign it. VLAN 2 to int range F0/1-15. Switch port mode client. Oh, look at me. You see? Switch port mode access. Switch port access VLAN 2. Right, for the students. And then now we're going to go ahead and do the port security. Switch port security, which turns it on. Then we're going to do the MAC sticky. Then we're going to up arrow and do the max 1. I mean, you said 1, yeah, because we're ruling RFS, of course. Okay. And then violation or viol shut. Then we're going to turn off spanning tree by doing spanning tree on a tab, port fast. All right, you get that big old warning, so we want to guard against it. All right, spanning tree, BPDU guard. Yes, I tab big time. Enable, look at that. All right, but you can't do it on the test. Sorry. And you're not going to be doing this on the test anyway. You're probably doing this, setting this up, like the port security or something like that will be for the CCNA security. But hey, you may get asked questions on this. All right, do WR, Control Z. So now we're pretty much done. Show int trunk. Take a look at the trunks. There, the ports are trunked dynamically. Show VLAN. We see that VLAN 2 assigned to the ports right there. All right. We really don't need to look at this, but we'll look at it. Show VTP stat. Right. We see that, hey, we belong to the last domain. Right. And we are a client. All right. Number of existing VLANs. All right. So we have a whole bunch of information here. Very, very simple to do. It's repetitive, actually. All right. So we put them in the right VLANs. Okay. And we turn these into clients. This is our root bridge. Now it comes time to go to the actual router and do the inter-VLAN connectivity. And I'm going to change this because this is 20. It's not really VLAN 20 because I didn't take my 0. I didn't feel like redoing it. So we'll put VLAN 2 and make it match. All right, because it's just, I don't know, OCD that way. And put that there too. And put this here as 2. There we go. 2.254, 2.1. So it'll match up with VLAN 2. All right. So we're going to go ahead and go to the router. And we're going to say no. We're going to name our router, config T. And we'll just name it host name router 1. Now we're going to go straight into the VLAN, inter-VLAN. Now when you're doing a router on a stick, which is what you do, okay, for the CCNA, and for the majority of people out there do router on a stick, okay, you can't put an IP address on the physical interface. So basically all you do on the physical interface is do shut, and then you start doing your sub interfaces. So I'm going to up arrow F0.0.10 That's my first sub interface. Encap, short for encapsulation, dot 1Q, and then the number. This got to match the VLAN ID. Has to, required. Okay, and then the IP address. So we go IP address 192.168.10.254.255.255.255.0. Right? Pretty simple. That's the gateway address. So then we go and do the second sub interface. I'm just going to up arrow through there. So it's VLAN 2, and then encap 2. Now the sub interface, I try to match the VLAN, again, visualization purposes. And then I'm going to up arrow for the IP address. Yes, the less typing the better. And we put 2.254. All right. Do WR. Okay. Now I do have an interface F0/1 that's going to the public web server. So we'll put the IP address on that. IP address 1.1.1.254. 255.255.255.254. Oops. Bad mask. Yes, it is. Sure is. 0. And then no shut. So let's verify what we've done. Let's do a show IP in brief. Okay. And we see that we have our sub interface F02, and then we have the IP address is up. Sub interface 10, there's the IP address up. And fast Ethernet 1, the IP address, and it's up. All right. Another thing that I like to do is show IP route. Obviously, we want to take a look at the routing table, and we see that we're connected to these 3 particular networks. And the last one I do, you can just show run or show start. All right. And then I want to look at this right here. I want to make sure that this is going to match up with my VLAN. So I got my .1Q, 2.254.2, 10, 10, 10. So that's why I see 2, 2, 2, 10, 10, 10. For lab purposes, this is pretty cool. Doesn't work that way in the real world, obviously. Yeah, because the way things change, the numbers just don't really match up like we want them to. All right. So we should now have connectivity all the way across. All right. So I'm just going to pick one computer. And let's maximize this so you can see it better. All right. And let's ping. Let's ping our own gateway. Well, first let's take a look at our own IP address. IP config. All right. So then we want to ping 192.168.1.254. That's our gateway. And we get a reply. Then we want to go to 2.1, which is the computer on the other side. And let's see. Well, we have IPv version 4. It does have ARP. So the first ping should not go through. There we go. All right. So we have inter-VLAN connectivity, and then it's a web server. So let's not do it this way. That's kind of boring. Let's go to a browser, and let's just put 1.1.1.1, and there you go. You get to that particular server. So we are going all the way across. Some of you may be saying, hey, but I thought you had to be running NAT since you have a public and a private. Remember, this is not a real public interface. We are sharing the routing table, with our internal and external supposedly network. So there's no reason to run NAT on there because you know how to get from one side to the next. All right. So again, the purpose of this lab is to show the inter-VLAN connectivity by doing the sub interfaces and the encapsulation, which is 802.1Q or .1Q. That's what is used now. Okay. And especially for the CCNA certification. Again. All right, and then we implemented the spanning tree and the VTP modes, okay, and the trunking ports, which is very important. And we created VLANs up here, and we had them propagate down by turning not only the trunk ports on, not only by making these switches part of the VTP domain, but by turning these switches into clients as well. If all those 3 records that are not done, then it's not going to happen. They're not going to propagate to go down. All right, this is your inter-VLAN STP switch port security lecture. Okay, there's a lot of things in this lecture, so definitely pause it, look at it a couple times so you can get the commands down and understand what's going on. I will see everyone in the last lecture of this course. Now this course of this particular section. Thank you.